Greetings everyone, and welcome to my Python course. In this video, we are going to talk about the fundamentals of object-oriented programming, and why Python is an excellent choice for practicing this paradigm. Object-oriented programming is a program that revolves around the concepts of objects. These objects are instances of classes, which encapsulate data and behavior. Think of classes as blueprints, and objects as instances created from these blueprints. But why Python is object-oriented? Python is inherently object-oriented. Everything in Python is an object, whether it's integers, strings, functions, or modules. Additionally, Python's support for classes, objects, inheritance, and other object-oriented programming concepts empowers developers to write clean, modular, and reusable code. There are 4 concepts of object-oriented programming that guide the design and the structure of software systems. These concepts help in creating modular, organized, and maintainable code by promoting encapsulation, abstraction, and code reusability. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's start by talking about the encapsulation. Encapsulation refers to the practice of bundling data, which are the attributes, and the methods, which are functions that operate on that data into a single unit, called a class. It restricts direct access to some of an object's components, allowing control over how the data is manipulated and ensuring that the internal state of an object remains consistent. Encapsulation helps achieve data hiding, reduces unintended interference, and enhances code maintainability. Let's make it easier to understand. Imagine we have a magic box. This box can do cool things like change colors or make sounds, but we don't want just anyone to mess with it. We want to keep it safe and working properly. In computer programs, we do something similar called encapsulation. Instead of a magic box, we have something called a class, which is like a blueprint for creating special objects. This class holds both the data, which are the color or sound of our magic box, and the actions like changing the color or making a sound. But just like our magic box, we want to keep some things hidden and safe inside the class. So we put a lock on a certain parts of the class, so they can't be accessed directly from outside. In Python, there is a method called init. It is a special method used for initializing objects of a class. It's like a constructor in other programming languages. When we create a new object from a class, the init method is automatically called to set up the object's initial state. It allows us to initialize the attributes with some default values or values provided when the object is created. Let's make an example to understand. So to start a class in Python, we have to write class, and then the name of our class. We'll write dog, for example. And then we have to write our method. In this example, we are going to use the init method. So def as a function, and then underscore underscore init, and then underscore underscore, and then parentheses. And inside, we will write self as the first parameter in this method, so self. And then we write name, and then age. In the init method of the dog class, for instance, self refers to the specific dog object that is being created. It's like saying, "Hi Python, I'm talking about this particular dog." So now we have to write self.name equal name, self.age equal age. When we write self.name equal name and self.age equal age inside the init method, we are actually saying for this particular dog, set its name to the name I give you, and set the age to the age that I tell you. Keep in mind that the word self, we can change it into any other word. For example, here, we can delete it, and then instead of self, we can write any name, such as hello, for example. And then instead of self, it will be hello.name equal name, and hello.age equal age. But as a default, we will write it self. And then we are going to write another function. For example, def bark, as it's a dog. Inside we put self. And then here, return a message. For example, bark, bark, bark. Now, if we want to create a dog object and make it bark, we can do something like this. My dog equal to the name of our class, which is dog, and then we put the attributes, which are name and age. We will give the name as, for example, body, and age 3. Now print my underscore dog dot name. We got body. But what if we write my dog dot age? What will happen? Print my dog dot age. We got 3 because here we set the age to 3 and the name to body. So when we wanted to access the dog name, we write the name of our variable. We set here my dog, which is dog, the name of our class, and then here's the name and here's the age. So my dog dot name give body, and my dog dot age give 3. When we created a new dog object like my dog and body 3, Python automatically knows that self should refer to this newly created dog object. So when we access my dog.name later on, Python understands that we are asking for the name of this specific dog object, which is my dog. But we can't directly access the dog's age from outside the class. It's like the lock on our magic box. This helps keep our dog's information safe and consistent. And now let's talk about the second concept, which is abstraction. It involves representing complex real-world entities as simplified modules within a program. It focuses on the essential characteristics of an object while ignoring unnecessary details. Classes and objects are designed to provide relevant attributes and methods that expose only the necessary functionality to the outside world, hiding the internal implementation complexities. Let's give an example to understand. Imagine we are drawing a picture of a car. We don't need to draw every single detail like every bolt or wire. Instead, we draw the important parts that make it look like a car: the wheels, windows, and doors. In computer programming, abstraction works similarly. Instead of dealing with every tiny detail of a complex object, we create a simplified models called classes and objects. These modules only include the important attributes and methods needed to interact with the object. For example, let's say we have a class called car. We don't need to know how the engine or the transmission works inside the car to drive it. Instead, we just need to know how to start it, accelerate and brake. Let's write our example to understand. Class car, and start self, and we write return car started. And we make another function called accelerate. Write def self return car accelerate. And finally, def brake car stopped. So def make self return car stopped. Now we want to use our car object. We don't need to worry about the inner complexities of how the engine or transmission work. We just call the relevant methods to start, accelerate, or stop the car. So let's make our object my car equal to car, the name of our class, and then let's access the car. So print my car dot start. We got car started. We can also access print my car and then dot brake. We got car stopped. This abstraction allows us to focus on the essential actions of the car without focusing on unnecessary details. Now let's talk about the third concept, which is inheritance. Inheritance is a mechanism that allows a new class, like subclass or derived class, to inherit properties and behaviors, like attributes and methods, from an existing class like superclass or base class. Let's explain inheritance in simpler terms. Imagine we have a collection of toys, such as cars, planes, and boats. Each toy has some common features like color and size, but they also have unique abilities. Now, instead of creating each toy from scratch, wouldn't it be easier if we could make new toys based on existing ones? That's where inheritance comes in. Inheritance lets us create new toys which are the objects based on existing ones, inheriting their common features and abilities while adding new ones if needed. For example, let's say we have a class called toy, which represents a generic toy. This class might have attributes like color and size and methods like play. So class toy and def init self color and size. Now self.color equal color and self.size equal size. And now let's create the function inside the class. The function inside the class is called method. So let's make def play self and then return playing with the toy. So playing with the toy. Now let's say we want to create a new class called the car that represents a toy car. So instead of starting from scratch, we can inherit from the toy class. This means our car class will automatically have the color and size attributes, as well as the play method from the toy class. So class car toy inside def init self color size and brand. Now instead of writing self.color equal color and self.size equal size, we can use super. So super dot and then we put init and then we put the names of the attributes that we want to inherit. In our case, we want to inherit color and size from the toy class. So we put color and size. That's it. And then we notice that we only have attribute brand here. But do we have brand also in the class toy? No, we don't. So in this case, we have to write self.brand equals to brand. And lastly, we create a method called the drive. So def drive put self turn I'm driving the car. I'm driving the car. Now when we create a new car object, we don't need to define the color and size and play method again, because they are inherited from the toy class. We only need to define the unique features of the car, like its brand, and any additional methods, like drive. So for example, let's create my car. So my car equal to the name of our class, which is car, and then inside we put the attributes. The first one is the color, which is red. Second one is the size, which was small, and the third one, which was a brand. Example, Toyota. Now let's access our attributes. Print my underscore car dot color and print my underscore car dot print, and lastly print my underscore car dot the name of our method, which is drive. And here we have it. For my car dot color we got red, and for my car dot brand we got Toyota, and for my car dot drive we got the message, which is I am driving the car. Inheritance helps us reuse code efficiently and create new objects with similar features, saving time and making our code more organized. So in our case, because we already have class toy, and within the class toy we have self, color and size, when we created the class car, we can put toy inside, and we use super method to inherit color and size by writing super and then init, and we put inside the attributes that we want to inherit, which are color and size from class toy. And then we create a new object, which is self.brand, give us brand. We also created this new method, which is drive, giving the message, I am driving the car. But did someone notice something strange here in our code? When we wanted to access my car.color or the color, we wrote it without parentheses. But when we wanted to access our message or our method drive, we wrote my car.drive and then parentheses. So why? Firstly, I would like you to know that in case if I put here parentheses, I am going to get an error. It's called type error. String object is not callable. And is the same with brand. But why? In Python, when we define a method within a class, we typically need to use parentheses when calling the method. This is because methods are functions that perform actions or computations, and the parentheses indicate that we are calling the method and want it to execute. In our example, drive is a method defined within the car class. So when we call mycar.drive, we're telling Python to execute drive method associated with the mycar object. Since drive is a method that performs an action, printing a message, it needs to be called within parentheses to indicate that it should be executed. But on the other hand, for color, for example, it is an attribute of the mycar object, not a method. When we access mycar.color, we're simply retrieving the value of the color attribute associated with the mycar object. Since we are not performing any action or computation, there is no need for parentheses when accessing attributes. So, in summary, use parentheses when calling methods to indicate that we want to execute method and perform its action. And don't use parentheses when accessing attributes, as we're simply retrieving the value of the attribute associated with the object. And now let's go for the last concept, which is polymorphism. Polymorphism refers to the ability of different classes to be treated as instances of the same class through common interface. It allows objects of different classes to be used interchangeably, simplifying code and enhancing flexibility. Polymorphism is achieved through method overriding, where a subclass provides its own implementation of a method defined in its superclass. In simpler terms, imagine we have different kinds of animals: a dog, a cat, and a bird. Each of these animals can make a sound, but each makes a different sound. Now let's say you have a friend who loves animals, but they don't know which specific animal you have. However, they know that all animals can make sound. So you can tell your friend, listen, no matter what animal I have, just ask them to make a sound. Your friend doesn't need to know the specific type of animal because all animals can respond to the same request. In programming, polymorphism works similarly. We might have different classes like dog, cat, and bird, each with its own implementation of a method called makeSound. Even though these classes are different, they can all be treated as instances of the same class through a common interface. In this case, let's make our example to understand. So class, animal, then def, makeSound, self, and we write pass. And then we write another class called dog, write def, makeSound, then self, and then return Embark. Now let's make cat class and make animal inside. So class cat, we put inside animal, and we write for our method def makeSound, we put self, return meow, and then we make class bird and we put animal inside too. So class bird animal, we write def makeSound, stove, turn, chip. So now no matter which animal object we have, we can call the same method, which is makeSound, and it will respond appropriately. So we write dog equal dog, the class, cat equal cat, bird equal bird. Now what will happen if we write print dog and then the name of the method, which is makeSound, and we do the same with the other animals. So print dog dot make underscore sound, and print cat dot make sound, print bird dot make sound. The first one for the dog we got bark, and the second one for the cat we got meow, and the third one for bird we got chip. So even though we treat each animal differently, they all respond to the same request, just like in our example with the animals and their sounds. This simplifies our code and makes it more flexible because we can use different objects interchangeably, as long as they adhere to the common interface provided by the superclass. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel and hit the like button. Until next time, happy analyzing.